This is the homework helper for Workbook 7-2 in the 8th grade textbook entitled Parallel and Perpendicular Lines. Now I'm going to skip over question 1 because questions 2 through 7 are similar in that they're asking for the same information. The difference is in question 1 they're kind of asking for it all in one lump sum, and in 2 through 7 they're asking for it in parts. So let's go ahead and take a look at the illustration that matches 2 through 7 here. What we see is we have two parallel lines, line M and line N. And remember, what parallel means in essence is that if I drew those lines forever, they would never, ever, 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 ever cross. If we want to get really fancy and talk about slopes, they're lines with the exact same slope. Those two parallel lines are cut by this transversal, which is marked P here. All right? Transversal, that's simply a line that goes across two or more parallel lines. That's all it is. As you can see, that's created 8 different angles here, one of which we already have the measure for, and the other 7 really we could find. Notice they're only asking for 6 though, but we could find all 7 if we needed to. So let's start off with the one angle that should be really easy to find based on yesterday's knowledge. All right, we have a vertical angle that matches this 142. Forget for just a minute that there's all this stuff at the bottom. Look at what's left if I just look at what's at the top there. There's that X shape. And we learned yesterday that when you have that X shape, the angle that's across from a given angle is congruent to it. So I'd be talking about these two angles right now. If this is 142, this one also has to be 142 degrees. And again, that's because of vertical angles being congruent. So where we have question number 3 there, even though it's not the first one on our list, we've already found that one. That's 142 degrees. And when they ask us to justify, we're going to say it's because of vertical angles. Now, from that, we could really also find 1 and 3. 1 and 3 would not come from vertical angles, but would come from another thing we talked about yesterday, which is the idea of supplementary angles. Two angles that when put together equal 180 degrees, or two angles when put together, if we ignore the line that shoots off of them, really makes 180 degrees. So we can look at this a couple different ways to come up with either of the angles we're missing. Let's say we're going to look at this top part here, and we're going to ignore that line. These two together, this one that's marked 1 and the one that's already marked 142, if I ignore that line that's shooting off, have to make 180 degrees. So if this is 142, that means that this segment has to be 38 degrees, because that's how I'm going to make this go up to 180. Notice it also works heading down this line. If I forget this stuff off to the left here and to the bottom, those two together also make a line 180 degrees. Well, we already know this is 142, and if that's 38 like we believe it is, 142 and 38 do once again make 180. So either way, whether we go from 2 or the one that was already marked, angle 1 has to be 38 degrees. And the reason is going to be because of supplementary angles. Now, one of the angles they do not ask for here is number 3, but we can find number 3 because, well, there's 2 ways we can do it, both of which we've already covered. Angle 3 compared to this angle would be supplementary, or compared to this angle would be supplementary. So they'd have to make 180. Well, we already know from the logic we just used here it's 38 degrees. We could also say that 1 and 3 are across from each other in that X shape, so they would both have to be 38 degrees. It doesn't really matter which one you use. Either way, the result is the same. Angle 3 is 38 degrees. But at that point, you'd pretty much be stuck, because there's nothing from what we saw yesterday that translates down to 5, 6, 7, and 8. But we learned some things today that can get us down to 5, 6, 7, and 8. We learned about what we call corresponding angles. Corresponding angles are angles that are in the same relative location. For instance, this angle here that was marked 1 is above a parallel line and to the left of the transversal. There's another angle that has that exact same description. Angle 5 is also above a parallel line and to the left of the transversal. It has to have the exact same measure of that partner angle. So since this is 38 degrees, this one would also be 38 degrees. Why? Because of corresponding angles. And again, that simply describes angles that are in the same relative location. Now, that really covers us for everything at the bottom. Because what we could do now is we could then do exactly like we did in the top and play the supplementary angles going to 180, play the vertical angles 38, and we could fill in everything else. But let's look at some of the other things we talked about here today. We talked about alternate interior angles. Alternate interior angles are angles that are between parallel lines but on opposite sides of the transversal. So when we're talking about number 6, if we're using the alternate interior idea here, between the parallel lines are these 4 angles only. And again, we're talking alternate. Alternate meaning opposite sides of the transversal. Well, we know it's not going to be the same as this guy because they just don't even look the same. Right? It's not going to be the same as this guy because they don't look the same. But it would be the same as this guy. Picture if I took this angle and rotated it around 180 degrees. It's going to line up perfectly with the angle marked 6 there. So 6 and 2 have to be exactly the same. And since they're exactly the same, and we know that 2 is 142 degrees, that means angle 6 must also be 142 degrees. So 6 and 2 are related by alternate interior angles, and that angle is going to be 142 degrees. Now the other concept we talked about today is alternate exterior angles. Same idea, all right, but notice I changed one word. I went from interior to exterior. Well, interior meant we were between the parallel lines. Exterior means we're outside the parallel lines. So now we'd be looking at these 2 up here and these 2 down here. Again, these are between, right? So these 2 up here and these 2 down here would not be between the parallel lines. Right? And again, it's alternate, so opposite sides of the transversal. So if we were talking about number 7 here, for instance, well, if we look at this one compared to this angle, that doesn't make any sense. This angle looks really big, this angle looks like it's really tiny. So these 2 wouldn't make any sense to match up, all right, but they're not on opposite sides of the transversal. Right? This one is the one that's on the opposite side of the transversal. So since this one is 38 degrees, this one is also 38 degrees. And that's because of alternate exterior angles. Now another way we know that works is by comparing it to angle 5. Because notice that these 2 are across from each other in that X shape. Well, remember, that's called vertical angles that we saw yesterday. And vertical angles have to be the same. Well, 38 degrees, 38 degrees. They are the same. Number 8, there's a lot of ways we can get 8. We can do the alternate exterior thing. We can do supplementaries, but let's pick the easy one. Let's go with the verticals again. It's across from 6 in that X shape. So since this is 142 degrees, this one also must be 142 degrees because it's in the vertical angle set. So now if we go back and reference 1, where they're asking you to actually measure the angles, grab a protractor and start measuring. You're going to see the same relationships that we just saw. You're going to see that as you measure, that 1 and 4 and 5 and 8 are going to be the same, and 2 and 3 and 6 and 7 are going to be the same, just the same way they lay out here, just different actual physical angle measures, but the matches, the partnerships will be the same.